Hello again, fellow coders, and welcome back to the Apache Airflow with MWAA series. I'm excited to have you here for our sixth lesson. Before we dive into today's topics, let's quickly recap what we have covered so far. We have set up an MWAA environment with public access. We have ran multiple DAGs that integrated seamlessly, and one of them, which had RDS as a source and Redshift as destination. We have also explored logging and monitoring to troubleshoot and analyze DAG runs effectively. If you have been following along, you now have a solid foundation to run your workflows and gain visibility into their execution. In today's lesson, we are taking things a step further by diving into metrics, scaling, and performance in MWA. These are crucial for running workflows at scale and ensuring they execute efficiently. Here are things that we will cover. The key metrics that you need to monitor to keep your environment healthy. How to scale Airflow tasks effectively to handle large workloads. Tips for improving Airflow performance, including resource optimization and identifying bottlenecks. By the end of this lesson, you'll be equipped with tools to optimize your MWA environment and handle production scale workflows with confidence. Let's jump right in. Let's talk about the key metrics you'll need to monitor in MWA. Monitoring the right metrics will help you catch issues early and scale your environment effectively. Some of the most important metrics to keep an eye out on include the worker count. This shows how many salary workers are running in your MWA environment. This metric is not directly available in CloudWatch and will be derived from two other metrics. Then the other one is slot pools. You have to keep an eye out on your available pools to see how many tasks end up in queued. If there are too many tasks that and always end up in queued, that would mean that you need to scale out and add more workers. Then the CPU and memory utilization of the workers are important as well. You have to make sure that they are not overwhelmed. I recommend setting up a CloudWatch dashboard to visualize these metrics in one place. You can also configure alarms to notify you when certain thresholds are crossed. This will help you proactively manage your environment. We'll take a look at actually defining this using Pulumi in a few minutes.
So here we are looking at our Pulumi code. So the metrics that I ended up adding was let's scroll down a bit. Here we go. CPU utilization, which consists of CPU utilization for all the workers as well as the scheduler, Airflow scheduler, then the web server, as well as the database reader and writer. This is the database that Airflow uses for storing its all the metadata. So it's important to monitor that as well. Then the second one is memory utilization. Now for memory utilization, this we only need to monitor the workers because in this case, database would be for the database it would be different metric, which we are not actually taking a look at uh, in this Pulumi code. Then the third one being the slot pools. This is an important one as well, where we have to keep an eye out on especially the queued slot. If the queued slot has too many tasks running for a long time, that would too many tasks for a long time, that would mean that something's wrong with the MWA environment, and you need to go in and either tune it. Either you need more workers, or it could be possible that your tasks are just stalled. Then the last one that we are adding today is the worker count. Now, as I mentioned earlier, worker count is not available in directly in CloudWatch. So you have to take a sample of the metrics for the additional worker as well as the base worker, and then add them up to be like expression. Now this is how you would end up doing something like that. And while like actually making like this, you have to make sure that your stat is sample count and your period is 60. So what it ends up doing is like if you have like more values for a metric than 60 seconds, it would just like take the sample count and make sure that you just like get one value for 60 seconds, which like adds up as we can we'll just like see in a second. Here we go. I'm opening up the AWS console. I'm just opening my dashboard up. Okay, here you can see the worker count. Now the expression like gives me two because like I have two workers, one being additional worker and one base worker. Now taking a look at the slot pools, you can see that I have like 10 open slot pools, so that means I can schedule 10 tasks on my um, like Airflow instance at a given time. Then this CPU utilization looks like good enough for like all the tasks as well as this memory utilization. Now that we have covered monitoring, let's talk about scaling Airflow tasks in MWAA. Scaling in Airflow primarily depends upon parallelism, that is the maximum number of tasks that can run concurrently across the entire environment. Then the second part is worker concurrency. This controls the number of tasks a single worker can execute at a time. By worker over here, it would mean a salary worker. Task queues. By distributing tasks in separate queues, you can balance the load across workers. To demonstrate this, let me show you an example of DAG where we use dynamic task mapping to run tasks in parallel. The key takeaway here is going to be to bring balance between these parameters based on your workflow requirements and monitor the queue length to avoid bottlenecks. Now let's take a look at the sample DAG that we are writing up to uh, just like test out the Airflow's concurrency. Now if it like this sample DAG only has like three steps to it. One uh, just generates a bunch of numbers till 100. Then the second task just adds one to it, and then in the end we just like get a total sum. The second task, if you take a look at closely, uses dynamic task mapping, which basically uses the value generated from like generate numbers, and then basically schedules or creates multiple tasks for that particular generated values. So this being just a simple example, it's not doing much, but this is a powerful concept because now you can basically run like multiple tasks based on any value that you get from like a different source. So let's say you have like a database table based on which you need to generate tasks. You can do that using dynamic task mapping. Now that we are off that tangent, let's take a look at running this. I already like went ahead and ran this for the first time on the default setting which we had from our previous chapter, and it seems like this one took like around 4 minutes to complete. And taking a look at the dashboard, okay, I don't want this to be average. Let me update. Okay, this is maximum. So if you take a look at this, let me zoom in, or let me zoom in even further. Let's say 15 minutes. Nice. Maybe 30 minutes would help. Okay, over here we can see that the number of scheduled tasks actually rose when we started running the tag. The open pool slots stayed the same, which is what we expect. Now the cube, whoops, I think I deselected the others. Let me select them back. the queued pool slots stayed the same, while the running pool slots stayed 4. Now, Airflow is not like a real-time engine, so I'm guessing this is due to the delay Airflow has for actually like scheduling the task and running them. Because like what I'm going to do next is actually increase the concurrency per worker and see how that has an effect on running this particular tag. Seems this next tag run actually failed. Now, let's take a look at like why this might have failed. Heading over to the metrics count, I was actually just taking a step back. I was looking at the wrong metric for like for checking the running task. This is the right metric. Um, this one actually keeps track of the number of tasks that are running, whereas this one just has like the number of slots. That would mean the number of executors that are running. So this is on a cluster level, and you could ignore this. Instead, focus on the running task. Now, yes, coming back to why this one would have failed. If we look at the like what I had, the change that I had made was in main.py. I had updated this, like added the salary auto scale to be like auto scale worker to be 10 and 10. What this actually means is whenever a salary worker is started, it would end up like spawning 10 threads on or 10 processes on one salary worker. So because of this like added parallelism, even when the tag is actually not doing anything, it was causing problems. Heading over to the dashboard, we can see that the CPU utilization was hitting nearly 100%, where as well as the memory utilization was pretty high. So what I ended up doing was now I'm going to try reducing this and then see what ends up happening. So now I updated my like maximum number of workers to be 6, but kept my minimum to be 2. And as you can see that like when I ran that, it didn't make much of a difference. The reason is like Airflow needs time to like MWA would need time to auto scale as well. And over here, like in the last run, you can see that like it didn't auto scale above 4 workers, which essentially it ended up like not helping a lot. So what I ended up doing was like just to get the speed up, I updated the minimum workers to 6 as well, which would mean that it would provision all the 6 workers beforehand, before I run this tag. And when I did that, you can see that the execution time dropped by half, which is like, or more than half, which is actually great. Looking at this, now you can see like what tools you have in your back pocket in case you get stuck or in case you want to speed a DAG up. Now, all this is related to like specifically for MWA or like the salary executor, but there are multiple like parameters in Airflow as well, which is outside of the scope of this video, which I'm like not touching right now. I might actually revisit that in one of the later videos.
Finally, let's talk about Airflow's performance. A few tips to improve your Airflow's environment's efficiency. First, like you have to optimize task durations, breaking long tasks into smaller manageable chunks. This improves parallelism and reduces the risk of task failure. Then you have to leverage task queues using separate queues for like resource intensive tasks to isolate their execution. This would help you to better utilize all your cluster resources as well as make sure that like one resource intensive task doesn't like take over over all your environment. Then the third one is monitor your resource utilization. Keep an eye out on CPU and memory metrics to identify workers that might need scaling. Fourth, use efficient connections. Optimize your database queries, especially when working with RDS and Redshift, to minimize latency. If you notice tasks being in the scheduled state for too long, check your worker availability and ensure that your environment has enough resources to handle the load. As we head to concluding this video, I'm actually going to wrap up the MWA series with this video. I want to take a moment to share my plans for the future of the knowledge I'm sharing for Apache Airflow. While MWA has been a great topic, I'm now shifting gears to explore running Airflow on Kubernetes. Kubernetes offers unparalleled flexibility and scalability. And best of all, I can run it locally and I don't need to spend money on hosting it on AWS. Just my overall experience has been MWA seems to be pretty expensive. And if you already have a Kubernetes cluster, it might actually be better to just like self-host it. I'm still open to creating more of MWA videos if there is any interest. So if there is any particular topic that you would like me to cover, drop your suggestions in the comment below or directly reach out. I'll also leave my uh, I leave my email down in the description. Like, feel free to send. So stay tuned for this exciting journey into Airflow on Kubernetes. If you have enjoyed this series, please like and subscribe and hit the bell icon to get notified about our new content.